Okay, everybody, welcome to part 2 of the video in November 2020, question 4.2, maths paper 1. Alright, so now we're going to go on to question 4.2.5. They say, determine the equation of g to the power negative 1, the inverse of g in the form of y equal to da 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 da. So we just have to get the equation of g to the negative 1. So g is a straight line graph. So g of x is equal to half x plus 9 over 2. So we have to now get the inverse. Okay, so the inverse, we're just going to switch the x and the y's. We're going to switch the x and the y values in the equation. So we're going to have x is equal to a half y plus 9 over 2. And then we're just going to solve for y. So we solve for y. Just take that 9 over 2 over. So we got x minus 9 over 2 is equal to a half times y. You want y alone. So we're going to divide everything. We're going to divide this by 1 over 2. We're going to divide everything by 1 over 2. Okay, so I'm gonna work with decimals to make it look easier. So x minus 4,5 is equal to 0,5. Y divided by 0,5 divide by 0,5 divide by 0,5. You have to divide the x and the 4,5 both by 0,5 because the x and the 4,5 are two separate terms. Remember, plus and minus separates terms. So we're going to get rid of that 0,5. You put your y there. X divided by 0,5. Now, x divided by 0,5. Okay. Sorry for the light. Right though. So x divided by 0,5 is like you're saying that's a 1. It's like you're saying 1 divided by 0,5. And if you go on a calculator and you punch in 1 divided by 0,5, you get 2. So that's basically 2x minus 4,5 divided by 0,5. 4,5 divided by 0,5 is 9. So that's minus 9. So that is basically the inverse. Y is equal to 2x minus 9. Which can also be written as g to the negative 1, x is equal to 2x minus 9. But the examiner wants it in the form of y. So we're just going to stop there. Okay, y is equal to 2x minus 9. Okay, so that's how we got the equation of my inverse. The last question is a nice question. It's a bit of a challenge, but let's just go for it. So let's just go for the next question. So the next question, they say that if h of x, so they're saying that 4.2.6 now, if h of x is equal to g to the negative 1x plus k is a tangent to f. So they're saying that this h of x is a tangent to f. Determine the coordinates of the point of contact. Determine the coordinates of the point of contact between H and F. So we know that, let's say for example you have a graph like this. Okay, so let's say this is our parabola, which is f, right? F is a parabola. So this equation is the equation of my tangent. They're saying that this equation over here is a tangent to f. So let's say this is a tangent. We know that this is generally a tangent, and a tangent touches the point of my parabola. And what do we know about a tangent? The main thing we have to know about a tangent is that the first derivative of my parabola is equal to the gradient of my tangent. That's the main thing that we have to remember about tangents and parabolas. Okay, so In this question, they say this is the formula of the tangent to f, and they say determine the point of contact. So this point of contact is this point of contact over there that has coordinates x and y. We don't know what's x, we don't know what's y, but we have to now get x and y. Okay? So this is h of x, right? And this is f of x, which is the parabola. Now, h of x, I'm gonna rewrite it here. H of x, so g to the negative 1x, we got the formula here, 2x minus 9. So that is going to be 2x minus 9 plus k. Okay, we just stop there. I don't know why the k is there. The k is just there because it's there. Don't stress too much about the k. The main thing I want to point out is that the first derivative of the parabola gives you the gradient of the tangent. Now let's get our first derivative of the parabola. We might see if it's going to help us. Do it. Don't leave this question blank. Don't leave it blank. Please don't leave it blank. So my parabola is f of x is equal to a half x plus 5 squared minus 8. Okay, but I need my general formula of the parabola, my standard formula of the parabola. So I'm gonna have to multiply out. So that's 10x plus 25 minus 8. So that's a half x squared plus 5x plus 25 over 2 minus 8. So that's a half x squared plus 5x, 25 over 2 minus 8. 5 over 2 is about 12,5 minus 8 is 4,5. So that's about plus 4,5. So this is the formula of my f of x. Now the first derivative is equal to 2 times a half is 1. 1 times x is x. And 2 minus 1 is 1. So you just keep it x and you plus 5. Because 1 times 5 is 5. And 1 minus 1 is 0. And x to the power of 0 is 1. So we don't have to write that. And with the constant, in our first derivative, our constants fall away. So that is my first derivative. Okay? My first derivative is x plus 5. Now we know that the first derivative is equal to the gradient of the tangent. Now what is the gradient of my tangent? Do you know what the gradient of my tangent? I also didn't know this, but guess what? It's grade 9 work. I'm going to go back to grade 9 work. Grade 9 work tell us that y is equal to mx plus c, and the m is the coefficient of x is my gradient. So if you go down and you look at the formula of h of x, the coefficient of x is my gradient. So 2 is my gradient of my tangent. So we can equate the first derivative to the gradient of my tangent. So the first derivative is x plus 5, and we equate it to 2. And we solve for x. 2 minus 5, and x is equal to negative 3. That x value is the x value of my point of contact. This over here is my POC, my point of contact. I'm going to call it the POC, the point of contact. So I'm going to go again. The question that gave us the formula of the tangent. That was the formula of our tangent. Okay? G to the minus 1x, which is the formula of my inverse, which we calculated here, 2x minus 9. So it's 2x minus 9 plus k. The k is just here to confuse you. Okay? And they say that this is a tangent to the f, which is the parabola. Determine the point of contact, the coordinates of the point of contact between h and f. So we know the main thing, whenever you see something like this in the exams of a parabola and a tangent, always remember that the first derivative of my parabola is the gradient of the tangent. So we look at the parabola, we got the standard formula of the parabola, then we got the first derivative to be x plus 5. Now the first derivative is equal to the gradient of my tangent. What is the gradient of my tangent? The gradient is the coefficient of x, which is 2. So therefore, x plus 5 is equal to 2. Solve for x. That x is the x value of my point of contact. That x lies on my parabola and it lies on my straight line graph. So what we can do to solve for the y value, we can substitute the x value into my parabola to calculate the y value. You understand? We can't substitute the x value into my straight line graph because we don't know what's k. You understand? So in my parabola, x is equal to negative 3. So then y is equal to a half times negative 3 squared plus 5 times negative 3 plus 4,5. So y is equal to a half times 9 minus 15 plus 4,5. So y is equal to half times 9 is 4,5. 4,5 plus 4,5 is 9. And 9 minus 15 is minus 6. Okay? So y is equal to minus 6. So we got the x value, we got the y value, and therefore my point of contact is negative 3 and minus 6. Okay? So very, very important to understand that the main thing to understand is that the first derivative is the gradient. The first derivative of my parabola is the gradient of my tangent. That's got the first derivative. And that x value of my first derivative is the x value of my point of contact. So we can equate that first derivative to the gradient of my tangent, which was 2, the coefficient of x, calculate x, solve for x. That x is the x value of the point of contact. We substitute that value back into my parabola to get the corresponding y value, and therefore negative 3 and negative 6 is the coordinates of my point of contact. So thank you everybody for watching this video. I hope it make sense. Peace.